particle motion. Here we go with some of the problems that you asked about. Number 8. I think, Katie, you asked about number 8, and I think you were onto something. I think there was a typo or something wrong with the multiple choice, the answer key maybe. They give us a position of 9t minus t squared, and t is between 0 and 9, and they're asking for the speed and the acceleration of at the end time of the interval, so over at 9. So speed's going to be given with velocity, so the speed would be 9 minus 2t. Actually, no, it's not incorrect. It's not incorrect. Okay, so they want this so velocity is, let's do v of 9. 9 minus 18, so negative 9 for the velocity. But speed, so speed is like the odometer on your car. Velocity has direction. So the speed is 9, what are we in, meters per second. And then acceleration, so we need to do the derivative again. Acceleration is negative 2. You're decelerating, and that's in meters per second per second. So that would be choice, what is it? A. So choice A would be the correct choice. That's why it's not C, is because it's speed, not velocity. All right, then the next one was number 10. So number 10 has the rock being thrown up in the air. The position is given as 120t minus 10t squared. And they're asking about how high the rock will go and how long it takes the rock to reach that high point. So this is going to be a parabola. And here's the high point right here. And so think about it. We're doing tangent lines. Slope of the tangent line right there is going to be 0. So let's find the velocity, or the derivative. So 120 minus 20t. Set that guy equal to 0. We can factor a negative 10 out. So I get 12. What do I get? Just kidding. Don't factor a negative 10 out. Factor out a 20. 20, so you get a 6 minus t equals 0, so t equals 6, so it takes 6 seconds to get there. And now we want to know how high it is. So at 6 seconds, what is its position? So s of 6. So plugging in 6, 120 times 6 minus 10 times 36. And we should get 360 when we do that. All right, then 11. The deflection of a 6-meter beam as a function of the distance x. I think they're talking about laser beams. I'm not entirely sure. But here we go. We've got, for number 11, y equals 0.0001 times x to the 5th minus 36x squared. They want you to find the second derivative, y, with respect to x. So the second derivative, first distribute and then find your derivative. So y equals 0.0005 x to the 5th minus 0.0036 x squared. Then go ahead and find the first derivative. Not 5, 1, there we go. Now you can find the first derivative. So 0.0005 x to the 4th minus 0.0072x. They want the second derivative, so do it again. 0.002x to the 3rd minus 0.0072. And they want it at x equals 3.2. So plug in 3.2 for x, and you should be good to go. Number 13. All right, they give the velocity of a moving body along the s-axis. So here's your velocity, t squared minus 5t plus 4. They want to know when the velocity, the body's velocity is increasing. So I want to know, when is this guy increasing? So the velocity is becoming greater. That means that it's speeding up, or it has positive acceleration. So we need to find the acceleration. So 2t minus 5, set it equal to 0. So we'll find the turning points where it either changes from acceleration to deceleration or deceleration to acceleration. And it changes at 5 halves. So we'll do a little sine line graph at 5 halves, plug in a value below 5 halves, let's say 0. We get a negative. Plug in a value above 5 halves, let's say 3, and we get a positive. So it's going to decelerate, then accelerate. The question is asking, when is the velocity increasing? So it's increasing on the interval t greater than 2.5. So that's 13, and I think there was one more. Yeah, 16, which looks an awful lot like number 10. I think it's like the same problem, but it's just one little tweak in it is all. So 16, they give you the rock again being thrown. People throw a lot of rocks, don't they, in calculus? It's kind of weird. Minus 6t squared. How high does the rock go, and how long does it take to get to its highest point? So remember, it's a parabola. Here's the highest point. So the derivative would be equal to 0 up there. So let's find the derivative, which is the velocity. So 120 minus 12t. We can factor a 12 out of this, set it equal to 0, right? Factor a 12. So we get 10 minus t equals 0. So t equals 10. So at 10 seconds, it's going to hit this high point. So let's find out how high that is. So find s of t, or s of 10 rather. So 120 times 10 minus 6 times 100. And you math it, right? And you should get 600 for that. So there you go. Let me know if you have more questions.